So this
Oh my god.
region here, all right, we have the curve y equals 3 and the x-axis. Those are our boundaries. And then we also have from 0 to 4, so those are like kind of vertical lines for our boundaries. We create this rectangle. Rectangle is 3 by 4, so it's 12 units squared. Okay? Here, our region was a non-horizontal line. It was like a diagonal line there. Okay? We can find the area of the region between 1 and 3. So there's our vertical boundary lines right there. And then, again, the x-axis. We broke it up into a rectangle and a triangle. Added those two areas together, and we got the area of 6 units squared. But also, it's a trapezoid. We could have used the trapezoid area formula, 1/2 base 1 plus base 2 times height. Semicircle, right there. So semicircle is half of the area of a circle. So that's 1/2 pi r squared. So we just get the area there. Okay, easy peasy. All right, same deal here for the triangle. Up top, 12.5 units squared. And then on the bottom, we have what we're going to be working with eventually. These curves that don't have geometric shapes that we can use to precisely find the area, but we can break it up into geometric shapes and find an approximation of the area. So we made, again, from 1 to 5, was this interval, and we kind of broke this up into like rectangle and a triangle here and a triangle here. All right, some people did it differently, just did all like rectangles or something like that, and that's fine. But again, with our approximation, the way we did it here, it would yield it over approximation. Over approximation. Okay, so in this section, we're going to examine the problem and find the area of a region in the plane. So that's what we're looking at. So flip the paper over, and now we're going to look at another curve, a curved curve, right? Not those like straight line curves that aren't really curves in the first place. All right, it's another actual curve. So, reading the directions here, it says, suppose you have to find the area under the curve, y equals 25 minus x squared from 0 to 4. All right, so from 0 to 4, so from 0 out to 4, here's where 4 is, right there, and so that means we're going to kind of like have this vertical boundary line right here. All right, here's our top boundary line. It's going to be that curve. Right, we also have the x-axis as our boundary line. And then the y-axis as well, because x equals 0 is the boundary line. So there's our region. Part of the difficulty of these problems is correct identifying your region. So this is not, elementary, dear Watson. That's right. So I'm going to go ahead and shade in this region too, just to add emphasis to the exact regions that we're trying to find, the regions area that we're trying to find. Okay, that's our region. We're going to examine some methods that we can utilize here to help find the area of this region, because clearly it is not a geometric shape. It's not a geometric shape. All right, so method 1, we're going to divide the region into 4 rectangles. So if we're going from 0 to 4, we're going to divide into 4 rectangles where the left endpoint of each rectangle comes just under the curve, and then find that area. So what I mean by that is we're going to take our interval here from 0 to 4, and we're going to divide that interval into 4 intervals, 4 sub-intervals. Okay? So if our current interval is from 0 to 4, if we divide that into 4 equal sub-intervals, what will the width of those sub-intervals be? 1. Yes, we're going to go from 0 to 1, and then from 1 to 2, 2 to 3, and then 3 to 4. So 1, 2, 3, 4. All right, 4 sub-intervals there, each of width 1. All right, the left endpoint of each, so our rectangles are going to, this is going to be this is like the width of our rectangle here, and then we're going to determine the height of our rectangle such that the left endpoint of the rectangle comes just under the curve and find the area. So what that means, oh my gosh, that's really confusing actually, now that I'm thinking about that. It's just right endpoint. Okay, so basically it's like we're going to use the left endpoint to determine the height of the rectangle. All right, so here's our rectangle, goes from 0 to 1. All right, but using the left endpoint here, so that means our rectangle is going to go up to 25, and then straight over like that, and on down. All right, so there's our first rectangle there. Okay. Next subinterval. The height of that rectangle is going to again be determined by the left endpoint here, which is at x value 1. At x value 1, we're going to go all the way up to like halfway between 22.5 and 25, like right there.
Oh, we can like not.
Okay. Well, we can figure out what that value is going to be.
Oh, no,
What is that height exactly going to be? So I'll draw it out here, and we'll figure that out here in a second. But think about that. How can we actually figure out what that height is? All right. All right. From 2 to 3. From 2 to 3. All right. Again, we're going to use the left endpoint, so it's right there. There's the left endpoint of the rectangle, so we're going to go over and draw on down. Okay. And then from 3 to 4, again, left endpoint. Right there is where it meets the curve. Straight over and on down. All right, and so we create then so there's our 4 rectangles. So we're going to find the area. So let's find the area of rectangle 1. All right. What is the area of that rectangle? Well, we know the width is what? 1 times, and what's the height of that rectangle?
25.
25, right? It goes from 0 all the way up to 25 there. We can see that in the graph. So then the area of that rectangle is 25 units squared. Okay, let's look at rectangle 2. All right. What's the height of that rectangle?
Now we're going to have to do some math.
It looks like it's between 22.5 and 25, but how can we figure out exactly what it is? Plug what in? Plug 1. Okay, so the x-coordinate of this point is 1. Plug that 1 into what?
Y.
Right. What's determining the height of this rectangle? It's this curve, isn't it? What's the equation for the curve? Y equals 25 minus x squared. So we want to find the y value at 1 of this curve. So 25 minus 1 squared, which is 25 minus 1, is 24. So it's 1 times 24. Again, the width of a rectangle is 1. It goes from 1 to 2, so that's the width of 1. So we have a 24 unit square rectangle there. All right, let's do rectangle 3. Again, the rectangle's width is 1. What is this rectangle's height going to be? So, yeah, 2 is the x-coordinate. That's determining it. So 2 squared is 4. 25 minus 4 is, 21. Yeah, there's a function right up here. Yeah. All right, and last but not least, rectangle quattro. Again, the width is 1, and the height is 3 squared is 9. 25 minus 9 is 16. So you get 16 units squared. And so the area then, if we add all those up, 5 plus 4 is 9, plus 1 is 10, plus 6 is 16, 1 plus 2 is 3, 5, 7, 8.
168.
Did I add my
86.
86 units squared. 86. 86. All right, so at the bottom, is this an over?
I think it was 85.
Ocho say so. So is this an overestimate or an underestimate? Let's go to Mac. What do you say?
Over.
It is an overestimate, and how do we know? Yeah, our rectangles are going above and beyond, right? We're getting all this extra space, extra, a little bit extra there. So yeah, it's an over.
Doesn't it not count though, like the little part on the end that you make up for the part that?
But remember, our interval is only from 1 to 4. So the actual region we want is this red space. So we actually completely ignore this. We are only interested in trying to find the region of the red space. There, thank you. Okay. So, back at my desk. Okay. So is that clear then, Mac?
Yeah.
Okay. All right, flip the page. Turn the page.
Wait, that goes with something else.
Too easy?
No, I just want to let you know that I struggled really hard.
I'm sorry. You can have some snow days to think about what happened.
Recuperate.
All right, let's try this one now. So now we're going to divide this region into 4 rectangles where the right endpoint of the rectangle comes just on the curve. So basically we're going to use the height of the right rectangle now. Again, don't forget we have it's 25 minus x squared is our curve here. And again, we're going to go from 1 to 4. So there's from 0 to 4, not 1 to 4. So there's our top curve, top boundary, till we get to the 4, sorry, and then there creates that vertical there. We have a vertical boundary here, and then the x-axis is our 4th boundary, creating this enclosed region. Like so. Okay, that's our region we're concerned about. All right. So the width of this interval, so Joey, what's the width of the full interval here? What's the full length of that interval? 4. And if we want to divide it into 4 equal subintervals, that means each subinterval will be 1 in length. So from 0 to 1, 1 to 2, 2 to 3, 3 to 4. So again, there's 1, 2, 3, 4 equal size subintervals. Good. All right, so for this first rectangle here, remember we're told we're going to use the right endpoint to determine the height. So I'm going to start from the right endpoint of this first rectangle, go up, till we hit our curve there, and then over. And then back down, maybe over here. Okay? So there's our first rectangle. Slightly different, because we're using the right endpoint now to determine that height. All right? Questions so far? Okay, rectangle 2. Again, the right endpoint. So that's the number 2 here. So you're going to go up to the curve, over, and a question.
So would this be like an under approximation?
Yes, exactly right. That's what we're leading up to here. It's going to be an under approximation. Okay? And then finally, 4. There you go. And so, yeah. So again, the red region is the region that we're trying to find the area of, and then our approximation method is the black rectangles there with the hatch.
So for our 4th rectangle, how do we know that that line on the top is exactly at the 0.5 or the 0.75 between 7.5%? Like how do we know it's exactly in the middle?
We don't,
Okay.
but we can figure out the value, right? Right.
Oh, there's an nice.
Right, don't forget, this is the same equation as when we did on the first one. Oh, you weren't here for that. Okay, sorry. So yeah, we were using this curve. This curve has an equation. It's the equation of y equals 25 minus x squared. So, exactly right. So, rectangle 1 here. All right, rectangle 1. Nate, what will the dimensions be for this first rectangle? Its width is what? 1. And what's the height of that rectangle?
I'm going to go with probably 23.5.
Okay, so it is actually exactly 24, and here's how we can tell, right? The height of this rectangle is being determined by this x-coordinate. Oh, sorry, the x-coordinate's the matching y-coordinate there, right? At 1. The curve here, Nate, is the curve 25 minus x squared. So if we want to find the y-coordinate, the height of this x-coordinate of 1, you just plug it in. 25 minus 1 squared is 24. You just use the curve there. And so it's, yeah, just 24 units squared. All right? Rectangle 2. So what's rectangle 2 going to be then, Nate? What will its dimensions be? A width of 1, and its height will be all right, so let me help you get started here. This rectangle 2, so it's got an endpoint at 1 and at 2. Which one did we use to find the height of the rectangle? Do we use 2 or 1?
I was in the wrong x value, that's why.
Okay. 21, exactly right. There you go, 21. Exactly, it's the right endpoint here we're using, so it's 2 that we plug in. 2 squared is 4, 25 minus 4 is 21. Good. Alright, thank you. Let's go to... Alright, so Austin, rectangle 3. Well, its dimensions be?
1 by 15.
1 by 15. Okay, yep. 3 squared is 9. 25 minus 9, 16. Right? Yeah, 16. Yep. 16 units squared. Okay, very good. Thank you, Austin. And Caleb, rectangle 4. What will its dimensions be? 1 times, 9. So 4 squared is 16. 25 minus 16 is, in fact, 9. And so we add all these bad boys together here. And 4, 10, 1. Okay, so it's like 20, I guess. So 2, 4, 6, 7. 70?
Yep.
70 square units.
Yeah.
Okay, is the area. And again, Anna already identified that this was a what? Over approximation or under approximation, Anna? Under approximation. Question? So, great question. Right. So good point. So between these two, right, from the first one, we know that we said 86, but that was clearly an overestimate. And then for 70, that's clearly an underestimate, so we know the actual area has to be between 86 or 70. All right, so maybe not a bad idea here, Tyler, would be to find the like the average of those two. So what would the average of those two be? 78? Yep, 78. You're right, 78. Is it 78 then? So actually, I can find the actual area for this. Let's do one more method though first, and then I'll tell you what the actual area of this region is. Okay, for comparison.
There's more space that you're under approximating more of the curve, like going out.
Bending out. Exactly right. If you guys can't hear what Caleb just said there, okay, Caleb, you want to say that one more time?
The under approximate loses more because the curve goes out.
It bends out. So our error is more great. That is the error. That is the difference between the actual and the estimated value. The error is greater. The error is greater for the under approximation because we're bending out. So we are under approximating more than we are over approximating because we're bending out there. Okay, so it results in a greater error in the under approximation. So it's probably, not quite 78, but still it's going to be close potentially. Let's do one more method here, And again, we're going to take the same region, all right, same curve, y equals 25 minus x squared. All right, same region from 1 to 4. So curve down to the 4, and then vertical line, horizontal line on the axis. And again, 4 subintervals, so 0 to 1, 1 to 2, 2 to 3, 3 to 4. And again, 1, 2, 3, 4 of those. I'll get my shading in here. Alright. So there's our region again. But now, we're not going to use the left endpoint of a rectangle. We're not going to use the right endpoint of a rectangle. We're going to use the midpoint of each rectangle to get the height. The midpoint of each interval. What's that? Yeah, just under. The idea is, so it's like basically touching the curve. I don't know why it says just under. I think I need to change those words there. I don't like that. But anyway, the idea is that we want to intersect the curve there. So this first rectangle, what's the midpoint from 0 to 1 here?
0.5.
The midpoint from 0 to 1 is 0.5. So 0.5 is the thing that will determine the height. So we'll go up the middle of that rectangle to this point right here. It's not quite so obvious, but it's still going to have a width of 1. Okay, so there's that first rectangle. It's harder to see because it's so, narrow up there. But this is our first rectangle there. All right, our second rectangle here. Chanda, what's the midpoint of this interval? 1.5, right, so again, we're going to go up from that 1.5 to right there, and then we're going to go, we're going to use that as the height of our rectangle. So something like that. I didn't quite do a great job there. Okay, better. So now what's happening in this method here that's maybe making it a little bit better? Yeah, Tyler?
The upper right corner is making up for the upper left distance.
Yeah, we're hoping here that some of this overestimate was going to cancel out with some of this underestimate that we're experiencing right here. So we'll see how that works. Okay, we're hoping that it at least cancels out some. Okay. All right, 3, the third one here. Let's see. So Brittany, what's the midpoint of this interval right here? 2.5. So we're going to go up to the height above 2.5, and again, that rectangle there with the width of 1. To go through that. And then finally 4, its height is like the 3.5 there, about 350. Okay. So now we want to find the area of these rectangles. All right, so let's see here. Rectangle 1. Well, what's the width of that first rectangle? Still 1. What's the height of that rectangle, though? Yeah, it's 25 minus 1/2 squared. So we could just use our calculator if we wanted to, yeah. So 25 minus 0.5 squared is 24.75 units squared. Okay? Well, I could just do the table, that's true. So, Brandon brings up a really good point here, folks. We could actually, since we're going to be doing a lot of repeated calculations here, okay, the only thing that's going to be changing, let's actually go through that. That's actually a very helpful idea here, because this is a good learning experience, and it's got a little bit of programming kind of aspect to it to save us some time. All the rectangles are going to have a width of 1. All the rectangles they're going to have the heights determined by 25 minus something squared. Right? Isn't this going to be true? The only thing that's changing is our x values right here. It's always going to be the curve 25 minus that x squared. The width's always going to be 1. And so to make this real easy for ourselves, if we go to y equals, and we type in the y equals 1 times 25 minus x squared, like that. That's the generic kind of area for any of those rectangles, right? It's 1 minus 25 minus x. X is the unknown amount there squared. We can go to our table now, second graph, and let's just type in some numbers. So 1/2 was the first one. Let's just see if it works. Yep, 24.75. All right, let's try 1.5. That's the next midpoint right there, right? Next midpoint, 22.75. All right. So sorry, I should put 1.5 in the little blanks there. Now this one's 2.5. So we'll do 2.5, enter, and sure enough, 18.75. And we'll try 3.5 then. 12.75. This makes things so much quicker. Okay, the calculator takes care of it for us. It's a little bit of programming understanding there, but Brandon brings up a very good point. It saves a lot of time there. All right, very useful for you guys to be able to do that. So we can now add these up. 24.75 plus 22.75 plus 18.75 plus 12.75. 79 units squared. Now what did we say was the midpoint? 78, didn't we say? So that was halfway between the upper and lower estimates. Here's 79. Okay, now, here's the next question though. That is still not the exact area. Would we consider this to be an over approximation or an under approximation?
I'll say it's a close one.
Over. It's slightly under.
So yeah, if you look here, for example, let's look at the most kind of pronounced error here in number 4, okay? The most pronounced because it's the most error, kind of in both cases. If you look here, this little triangle right here is bowing out, right? It's kind of third side right here. I guess the hypotenuse is kind of bowing out, whereas this one's bowing in. So the amount that we're under approximating, the amount we're missing, okay, is kind of greater than the amount that we are over counting for.
Well, decreasing at a faster rate.
Oh, I see what you're saying. So it might be, that could still balance it out.
It's like not really what you tell.
Yeah, we'll say question mark there. Okay, we'll say a question mark then.
Have you done the test?
Not sure. Yeah, can you untest? Yeah. Of course you can.
Wait, why is it a question mark?
Because it's hard to tell here about with the decreasing and stuff like that. I think we will get into like a more precise method, I guess I want to say. But you were right. It's harder to tell here. Yeah, it might actually be then a more over approximation is what I'm thinking now because we're decreasing so much. But you're right. That we also have the bowing too, so the concavity stuff. So we're not sure for right now. But let me give you the actual area. Ready for this? So here's the actual area. I'm going to do it real quick.
81.3.
We can't see this double.
Well, I'm not going to show it to you yet because I don't want you guys to know how to do it just yet. So it's 78.6 repeating is the actual area.
So it's slightly over.
So again, is an over approximation then, based on what which is what we were expecting, I think, from the fact that it's decreasing there. Yeah, a slight over approximation, just by 1/3. So what's the over approximation there? Yeah, it's pretty good. 78.6 repeating is the actual. Right. All right. So what I'm going to have you guys do for homework is the next three. 1, 2, 3. Joey. I can give you guys more because, you know,